The cell size of baryonic acoustic oscillations from first principles, a discussion between Henry and Thomas.
Hi, Henry. Great to meet you face to face finally.
Likewise, Thomas. So, this novel theoretical approach out of nowhere did get us collaborating rather quickly, didn't it?
It did indeed.
Is it okay with you if we leave chit-chat for the lunch break and first go directly to the matter that caught my attention in our last call?
Yes, let's. It's not that an observation like the distance scale of baryonic acoustic oscillations suddenly finds an alternative explanation outside the scientific community.
Well, it's not so sudden at all. Petri has had this program of his running for several years now, and it has already produced rather accurate postdictions about particle masses and charges.
Okay, perhaps we can have a look at those later. I just want to get to this idea about Higgs's boson producing the BAO cell size and how he can avoid using parameters to get any result at all.
Yeah, it's curious, isn't it? So, he sent me the derivation just this week. He's found a way to predict the BAO cell size directly from Logarithmic Pole Model's discrete arithmetic. I want to hear your opinion too. As to my understanding, it comes near to the observational range, a bit too near to be just a lucky coincidence.
The scale of BAO is one of our most precisely measured cosmological parameters. SDSS gives us about 147 megaparsecs, while Planck is consistent around 149. The uncertainty is only a couple of megaparsecs, a tight window. It's a hard-to-hit target by pure chance.
That's my reasoning too. Let me walk you through Petri's derivation, and we'll see where it lands.
I'm listening.
Let me start with the basics. LPM is a discrete, non-local model. It has closest relation to mathematics I've ever seen in a physics model. Integers play a fundamental role. They are intimately part of its very structure, producing both the fundamental constituents and the distances between them. The space doesn't exist on its own, but only as relations between poles and the aggregates they form.
This sounds a bit like some causal graph models. But those don't make a clear connection to how particles form, do they?
Yes, so Petri mentioned some similarity to Faye-Dowker's models about atoms of spacetime, but the resemblance concerns foremost the fact that the process itself of adding new poles to the system represents time.
Oh, I see. So the idea is not entirely new, but recycled. Time is not a dimension, and there's no problem about the arrow of time. But poles? What are they?
When in LPM we talk about the universe growing, we mean that the pole count increases. Poles are sources and sinks of logarithmic potential. This logarithmic potential is a mathematical construct to allow calculating accelerations between pairs of poles. Its repulsion and attraction rules have been honed to simplest possible. Simplest to do what? To allow the formation of finite-sized stable structure, such as particles, and, on the other hand, to accommodate the possibility of intense concentration of poles into aggregates, such as black holes. And, what's noteworthy, the model is non-perturbative.
Wow, not a claim one hears every day. And with black holes, this is totally untrodden territory. Why not talk about that instead?
Easy, hold on, I asked Petri about the same thing, and he wants to begin with the most straightforward postdiction to gain a tiny first bit of credibility. He's working outside the academy after all. No sense coming out with a 10-step hypothesis when an institutional scientist politely, or less so, loses interest in it after the first two logical steps.
Fair enough. I see the risks he is not willing to take. Still, did he answer to you or not? Are there any new findings about black holes?
There is an unprecedented, quantified, and clear connection one can make through LPM between black hole formation and the release of neutrinos. To the degree that he can calculate the number of neutrinos released by the supernova 1987A to a couple of orders of magnitude from the LPM. Allegedly. But we'll have to wait a moment. Petri promised to come back to me about it in a couple of weeks' time.
Okay, we'll have a call about that then. So let's go back to those poles. Logarithmic ones. Right. The name of the model was also that, Logarithmic Pole Model. You said that they are associated to integers.
Each new integer added to the system becomes either a nit or a pit, based on its parity. Nit like negative it, pit-like, positive it. As poles accumulate, they form aggregates in 4D. In this view, particles are mostly symmetric arrangements of these nits and pits.
So an electron or a proton is a particular arrangement of nits and pits. Even a photon is one.
The photon is the simplest one, a dipole. One nit, one pit. There is a zero potential halfway, perpendicular to the line segment joining them. Our 3D world lies at that zero potential. The internal zero plane of the photon aligns with that of the 3D universe. The dipole skims along the 3D, with its poles oscillating across each other on both sides of the plane, though never touching it. The crossing is only possible for an unbound dipole, and because of a rational number space constructed on integers in play, naturally excluding the zero. A zero distance never appears in LPM unless you mean the same pole, and poles don't have self-interactions, only pairwise ones.
Oh, that's something new. It might be called off-shell inducing of on-shell interactions. But what would cause the oscillatory nature of a particle?
The pairwise potential regarding the opposite poles is the absolute value of logarithm of z, where z is the distance between them. It has a natural minimum at unity. Let me show you some diagrams about that. I have it somewhere here. So these are the pairwise potentials between the poles on left and the related accelerations on the right. I let you view it for a moment. What most resembles the acceleration for each pole in such a pair is the old familiar gradient of the potential with the minus sign in front of it. Though we have neither seconds nor meters yet, for time there is the time step from the process of adding poles into the system, and then the dimensionless distances as rational numbers. One can use any direct fractions based on the integers we have available at a given moment in the system.
That's so totally outside the box too. So what would it imply? The oscillation is then inherent for any pole aggregate that has at least a pit and nit in it. That sounded funny.
Yes, any particle we know has that. LPM doesn't need fields to do the oscillation. It's a different playground altogether. Electromagnetism arises from interaction between 3D pinching dipoles and nits at distance.
So there is a secondary interaction imparted by a dipole onto nits farther away?
In case of the photon and its constant switching sides across the 3D shell, no durable electric potential arises. Electric potential is secondary, yes, and so is gravitational one. In addition to a dipole itself, both require bigger pole aggregates that are only anchored to the 3D shell by one dipole. The anchoring on one side of the 3D shell impedes the switching of poles across, as we saw photons do. Logarithmic potential is primary, electric and gravitational ones secondary.
If I got it right, they are working only because of the geometric relation the 4D pole aggregate has to the 3D space that cuts through it.
Yes, so indeed, both these secondary potentials, one can derive with the proper dependence on distance, 1 over d, where d is the 3D distance from the point where the dipole axis pinches the 3D shell. Gravity with that anchoring dipole relays the heftiness of the aggregate into an interaction with pits elsewhere.
Ah, so dipoles within aggregates that we know as particles contribute to electric properties through dipole to NIT interaction, and to the mass of the particle through dipole to pit interaction. Nice?
All from one primary interaction plus some basic combinatorics. That's the strength of the LPM. No quantum numbers introduced where none are necessary. Going back to the particle compositions, the electron has 3 pits and 3 nits. Pits at the center and nits in a triangle around them. 6 poles total. Proton has 5 of each. Again, pits at the center, but now nits in a pentatope around them. Pentatope is the 4D counterpart of the 3D tetrahedron, with 5 vertices rather than 4.
Why 4D context? Is it put into the model by hand?
Since we have limited time at disposal, you'll have to take my theorist's word for it. It isn't. Integers themselves, with an apt choice of arithmetic and algebra, produce the 4D context rather naturally. For instance, thanks to the algebra used, the S3 metric and the standard model symmetries emerge. And unlike with the conventional gravity-guided cosmology, S3 remains stable when the primary potential is logarithmic. Gravity only can rearrange poles along that sphere embedded in 4D.
Okay, we'll talk about that the next time. The particles you mentioned all have the equal number of pits and nits. Let me think. They are all stable. Are there aggregates of uneven proportions too?
Our 3D world cuts through the aggregates. If there are equal number of pits and nits, going to distance an internal zero potential plane aligns with the universal one, and hence the aggregate is stable. This is true for the antiparticles too, which have the same pole composition, unless of course they meet their antiparticle. Well, photon is its own antiparticle.
That's a lot to take in. And how about particles where nits are less or more than pits?
For example, muon has 3 pits and 6 nits, 9 poles in total. Tau also 3 pits, but 9 nits.
That sounds as if there is no room in 4D to put all those nits symmetrically.
In fact, there isn't. The more nits are, the quicker the particle decays. But going into the detail calls for another session. I mean, to explain it thoroughly, the theoretical foundation is based on combinatorics and not very complicated, but the tools needed are very unlike the ones we use elsewhere in physics.
I take your word for it.
So where was I? Yes, so the fundamental principle is that the universe grows by adding integers one at a time. Each particle harbors a permutative space of all possible causal sequences of its poles. They coexist as a sort of a superposition. To enumerate those sequences, many integers are needed. Particles can only exist once the number of integers reaches a threshold.
What determines the threshold for a particle? For the pole aggregate?
The number of distinct internal orderings that the poles can generate. The electron has 3 pits and 3 nets, 6 poles total. The number of possible causal sequences those poles can form is therefore 5 factorial, 120. You need 120 integers before you can create even one electron, or a positron.
Yeah, you said they have identical pole composition.
In the earliest phase, electrons and positrons are identical. There's no symmetry break between them yet. We call this undifferentiated substance paleomatter. Now, once the integer space is sufficient, not just one paleoelectron is formed, but 20. A question to you. Why is that?
And why should I know? Perhaps 120 integers or poles divided by 6 poles per paleo. What was it?
Paleoelectron. And that's the correct answer. To be precise, it works this time as there are equal numbers of pits and nits in a paleoelectron that successively become an electron or a positron. In 120 integers, there are equal number of odd and even numbers, so they also divide evenly, so no hassle there to turn all of them into paleoelectrons.
I assume we don't count on electromagnetism to work if the symmetry break hasn't happened yet?
Indeed, but now we must fast forward go to a natural endpoint of the particle creation, the Higgs boson.
I guess it then has a threshold of its own?
It has, yes. Higgs has 6 pits and 7 nits, so 13 poles in total. And now we get to the earlier results Petri has not dared to propose for publication, the mass formula.
A formula? For the mass of a particle? For real?
It's calibrated to proton, 10 poles, relative mass 9 factorial. Calculate for yourself, muon with 9 poles, relative mass 8 factorial. It's true that there are limitations by the 4D context. Number of nits exceeding the symmetric pentatope configuration begin to reduce mass by creating asymmetric causal links between poles of the aggregate. So for neutron with 4 pits and 7 nits around it, there is a 10-fold reduction in mass. So neutron's mass formula, based on 11 poles, is 10 factorial divided by 10, essentially giving the same 9 factorial relative mass as for the proton.
The results are near to the correct values, but the reduction mechanism already sounds tricky. Would this be the point to drop off politely?
LPM's particle structure model, decay, and other details call for another session. Bear with me for a moment, and I'll join the dots with the BAO scale post-diction.
Okay, so how do we get to the Higgs mass? That couldn't possibly be so directly obtained. By multiplying by integer factors. Come on.
That isn't too easy, in fact. Otherwise, before Petri, someone would certainly have discovered how the mass hierarchy is obtained from the combinatorial approach. As I said, he has been rather reluctant to publish anything unless his results connect to other areas of physics. Now, this is happening with the BAO scale derivation. May I go on?
Sure, why not? And now that I think of it, so far there are no actual ad hoc parameters appearing as there are in the standard model. I'm kind of curious to see how the story ends.
So I'll fast forward to the mass derivation of the Higgs boson. Neutron has, as I said earlier, 4 pits and 7 nits, and its mass formula is 10 factorial divided by 10. Now we can think arriving to Higgs's 6 pits and 7 nits by simply adding 2 pits to a neutron. The additional factors of this operation are 11 for 12th pole and 12 for the 13th pole. 11 times 12 equals 132. Ta-da! 132 times mass of the neutron, 939.6 mega-electron volts equals 124.0 giga-electron volts, or less than 1% from the actual value 125.1 giga-electron volts.
At this point, I must say, I'm having difficulty to let this sink in. The approach is just somehow so unconventional.
The match is not perfect, but a 1 to 2% discrepancy is not bad either for a model with one free parameter, the fixing of the relative mass scale to the proton's mass. Yes, what next? What we need for BAO calculation is the integer threshold.
Let me recollect. We want to know how big an integer space is required for the first Higgs boson to form. The Higgs mass formula gives it directly. 10 factorial divided by 10 multiplied by 11 and 12. So in total, 12 factorial divided by 10.
Once at the threshold, we divide the number yet by 12 to get the number of Higgs particles. Higgs has 13 poles, but as nits are 7 and pits are only 6, the number of Higgs we can form is not threshold divided by 13, but only threshold divided by 12.
I still follow. At this point, it's pure calculating. This is perhaps not so difficult after all.
Before going to the spatial extent of the BAO cells, I need to explain why nothing moves once Higgses have formed. The aggregates are packed incredibly tightly. Imagine a crystal-like structure where everything is locked in place. There's literally no room between them. The spatial degrees of freedom are absorbed into aggregates themselves. Inside each aggregate, the pole orderings are completely undefined. There's no internal causal succession, no order to them. Creating causal connections within an aggregate would mean decay, but decay requires space for the decay products to exist. From a potential minimizing perspective, this locked state is favorable. Decay would actually increase the sum potential of the system.
So particles literally cannot move or decay?
Correct. They're constrained on all sides by neighboring aggregates. This is the gridlock phase. It is entirely over only when a universal zero potential surface eventually forms. And as we discussed earlier, it is only at that moment electromagnetism and gravity emerge as secondary interactions. That is when there is a universal 3D subspace that they can cast their effects upon.
How long does this gridlock last?
That depends on the pole accumulation rate in those conditions. We don't know how quickly integers were being added. Our current understanding of time may not apply to that phase. What matters is the pole count. Eventually, after a huge number of poles accumulate, sufficient spatial extent develops. Distances between aggregates become large enough that they can finally first reorient themselves, then gradually they begin the translative movement. 2.
Why Higgs rather than some yet heavier aggregate?
Even though the Higgs is an extremely short-lived particle in today's universe, in the early gridlock conditions it was the largest aggregate that could be sustained in the four-dimensional context without decaying. Beyond that size, larger aggregates would decay at least back to the Higgs-sized chunks. Particle creation continues. New poles are still being added throughout the universe, generating new paleomatter. Finally, the universal zero potential creeps into a connected boundary surface we have earlier called the 3D space, or the 3D shell. At that point, the full paleomatter to matter-antimatter transition is complete.
What does that look like?
Based on how the universe shows itself to us today, it would seem the zero potential surface only formed at a point when some paleomatter became annihilated, leaving behind about 10 to the 79 poles and around 10 to the 89 photons. It looks like the Big Bang. Later on, the zero potential has nearly the spherical symmetry of a three-sphere, with some gaps where black holes form. But it's just a sign that the sum potential locally doesn't reach zero. The poles are there still, and the model itself can handle it.
Do you think you're deriving multiple observables from one mechanism, like the relative masses of the particles and the BAO scale?
Exactly. The same arithmetic that produces the striking particle mass hierarchy gives us also the BAO scale. That's a much stronger test than explaining one phenomenon alone.
I assume that new matter is not being produced once zero potential becomes universal and matter, and antimatter become distinct. Where do the new poles go after that?
Into photons mostly, or into particle-antiparticle pairs. One-sided creation of matter or antimatter is over.
This story is very different from the standard cosmology.
Fundamentally, in standard theory, space-time is assumed to exist first, with a matter-antimatter balance, annihilate almost entirely but not quite because of a postulated asymmetry. Then the universe expands, redistributing the initial postulated amount of matter. To the contrary, in the LPM poles create bigger and bigger particles until Higgs, then the wiggle room in between, then yet more space and more paleomatter around those initial Higgses. Higgs' loci imprint expands as the universe grows both matter-wise and in spatial extent by creating new poles. The zero potential forms, turning the majority of paleomatter into matter and giving a geometric explanation to the matter abundance over antimatter.
Do you now connect all of this to the cosmology?
Yes, but here I need to mention the geometry that describes the present universe. In LPM, the universe is an S cubed, a three-dimensional spherical surface embedded in 4 dimensions. No bulk inside, but the surface itself with regular 3-volume. This surface has ordinary 3-volume, measured in cubic megaparsecs, for instance.
Like how a sphere's surface is two-dimensional, even though it's embedded in 3 dimensions.
Yes, analogically, S cubed is a 3-dimensional surface in 4-dimensional space. Our entire observable universe lives on this hypersurface, though we only observe one hemisphere of it. The other half lies beyond our horizon.
So the full S cubed is twice what we can observe?
Yes, and this becomes important for the calculation. The cells imprinted during the gridlock transition are distributed across the entire S cubed, not just our observable half. We need to account for both hemispheres.
Curious. This reminds me about Julian Barber's Janus point. Somehow, beyond our cosmic horizon, the 3-sphere is expanding into the opposite direction.
The S cubed at our current pole count reflects the present state everywhere. This represents the full S cubed sphere of simultaneity at a given pole count. That's the entire present universe, all that exists right now everywhere. The pole-to-pole relationships define local yardsticks, forming a network across the S cubed. The continuous manifold we experience emerges between these discrete anchor points.
This is different from standard cosmology, which denies absolute simultaneity.
It is. The denial is needed in the standard cosmology as the space exists on its own, without matter, with tensors. That's a lot of structure to assume.
And was it so that Higgs cells were maintained by the primary, non-local logarithmic potential during the gridlock to S cubed transition?
Yes. LPM is fundamentally non-local. The logarithmic potential connects everything instantaneously through its geometry, not through signals traveling at the speed of light. During the gridlock phase, repulsive accelerations from the logarithmic potential reached everywhere simultaneously, maintaining the dense lock structure across the entire universe. The cells were imprinted globally during this phase. Once the zero potential surface becomes connected throughout the universe, it becomes where the observable domain is limited. That's when light, pit-knit dipoles, begin to propagate at speed c along the S cube. From that moment on, c becomes the speed limit. But by then, the cell structure was already locked in everywhere.
There, the speed of light is emergent, not fundamental?
The non-local logarithmic potential is fundamental. The speed limit and its universality is an actual consequence of the logarithmic potential. This is again a place for another session, if you are interested.
Could we now calculate the cell size in our 3D space? Those initial loci for Higgses become today's BAU cells, even if the naming now risks becoming obsolete. Let's see.
Sure we can. The roughly 4 million Higgs cells are distributed across this entire 3D shell right now, both hemispheres. They all exist simultaneously at this pole count. The question is, what volume does each cell occupy on the present-day S-cube?
Walk me through the calculation.
It starts with the Higgs threshold. Repeating once more, the neutron-rigged Higgs is constructed from a neutron by adding 2 pits. The neutron has 11 poles, 4 pits, and 7 nets. You add the 5th pit or the 12th pole, introducing a factor of 11. Then you add the 6th pit or the 13th pole, introducing a factor of 12. Combined with the neutron's factorial structure, 10 factorial divided by 10 from pentatopic reduction, you get 12 factorial divided by 10.
That's about 48 million.
47,900,160 to be precise. But that's not the cell count yet. The Higgs has 7 pits and 6 nits, 13 poles total. We divide by 12 to account for the parity asymmetry.
Giving roughly 4 million cells?
3,991,680 cells. Each represents a volume element where this Higgs configuration dominates the early universe structure.
Now, the volume calculation.
It's straightforward. We take the observable universe, our hemisphere of the 3D shell. We calculate its volume from the current radius about 14,260 megaparsecs. The volume we obtain is about 6.1 times 10 to the 12 cubic megaparsecs. We double it for the full S cubed, approximately 1.22 times 10 to the 13 cubic megaparsecs.
And then divide by the cell count?
Yes, 1.22 times 10 to the 13 divided by 3,991,680 gives volume per cell of about 3.05 times 10 to the 6 cubic megaparsecs.
Cube root?
144.9 megaparsecs.
That's within about 1.5% of the observed 147 megaparsecs. From pure geometry and arithmetic, I'm officially impressed.
No parameter fitting. The factorial structure of Higgs gives the cell count. The S-cube geometry, both hemispheres, gives the volume. The result matches observation within the measurement uncertainties.
Let me summarize. 12 factorial from Higgs via neutron channel divided by 10 from pentatopic reduction divided by 12 from parity asymmetry. Roughly 4 million cells. The S-cubed volume is simply the observable hemisphere doubled. Divide by cell count, cube root, 144.9 megaparsecs. Observed, 147 with uncertainties of a few percent.
So we begin from integers, proceed to the heaviest 4 D-contained aggregate possible, and further to the gridlock with additional paleomatter formation and space expansion, and yet through the emergence of the zero potential surface to the large-scale structure of the universe with the BAO cells.
This needs to be published. The derivation is transparent, every step can be checked, and the agreement with observation is striking. Even if someone rejects the LPM framework, they'll have to explain why the arithmetic works out so precisely.
I'll tell Petri about your opinion later today. This might be the cleanest cosmological prediction so far from the LPM.